Ever pondered the origin of everything that exists? Where did the universe come from? These are grand questions that have puzzled humanity for centuries. It's a riddle that stirs our curiosity, igniting a desire for answers. The cosmos, with its vast expanse of stars, galaxies, and dark matter, was it always there? Or did it have a beginning? The answer might lie in a theory as grand as the universe itself. Today, we'll dive into the fascinating theory that attempts to answer this question, the Big Bang Theory. Everything started with a singularity, a point of infinite density and temperature. The singularity, a term that might sound quite complex, but let's break it down. Picture a point so compact and dense that it's virtually impossible to comprehend. A point so incredibly hot that hot as a term fails to do it justice. This is the singularity. This singularity is where our current understanding of physics reaches its limit and breaks down. It's like trying to see past a brick wall. There's just nothing more we can perceive. Our theories, our equations, our understanding of how the universe works all come to a screeching halt at this singularity. And why is that? Well, when things get infinitely dense and infinitely hot, the laws of physics as we know them start to crumble. The forces we are familiar with, gravity, electromagnetism, the strong and weak nuclear forces, they all converge and become indistinguishable. In the singularity, they are all one and the same. But here's the catch. We don't exactly know what came before this singularity. It's a question that's been baffling scientists and philosophers alike for centuries. Was there another universe that collapsed into this point? Or did the singularity spontaneously appear out of nothing? These are questions we don't have answers for yet. Our understanding of time also gets a bit fuzzy when we talk about the singularity. You see, according to Einstein's theory of relativity, time and space are intrinsically linked. So if the singularity marked the beginning of space, it would also mark the beginning of time. Hence, asking what came before the singularity might be like asking what's south of the South Pole. It's a question that doesn't quite make sense in the context of our current understanding of the universe. From this singularity, the universe as we know it began. A single point of infinite density and temperature, a moment where our understanding of physics breaks down, and a mystery about what, if anything, came before. That's the singularity for you. Imagine a massive explosion expanding everything from that single point. Let's dive into the heart of the Big Bang, the event that birthed our universe. In the first moments, everything we know was condensed into a singularity, an infinitesimally small point of unimaginable density and heat. Then in an instant, the singularity expanded. This wasn't a typical explosion, but a rapid expansion of space itself, stretching and growing in every direction at once. This expansion was so fast, so incredibly quick, that it outpaced the speed of light. We call this the inflationary epoch, a brief period of time when the universe was about as small as a grain of sand, yet it grew to stretch across millions of miles. As the universe expanded, it cooled. The energy that was once packed into the singularity now filled the growing universe, and in this cooling energy began to transform. In the hot, dense conditions of the early universe, energy became matter and antimatter, creating the fundamental particles, the building blocks of everything we know. Protons, neutrons, electrons, and their antimatter counterparts came into existence. But matter and antimatter annihilate each other upon contact, transforming back into pure energy. So why is there any matter left at all? Well, for reasons we still don't fully understand, there was a slight imbalance in favor of matter. For every billion pairs of matter and antimatter particles, there was one extra matter particle. And it's from these survivors that all the atoms in the universe are made. It's hard to fathom, isn't it? That every atom in your body, the air you breathe, the ground beneath your feet, the stars in the sky, all came from this incredible explosion. And yet that's exactly what happened. The initial conditions of the universe set in those first moments of the Big Bang have shaped everything we see around us. This momentous explosion set the stage for the universe's evolution. Following the explosion, the universe began to cool and expand. This was not a simple process, but rather a series of stages that would eventually lead to the formation of everything we know and see today. The high temperatures and pressures of the newborn universe were not conducive to stable matter. For a while, it was simply too hot and too dense for anything we would recognize as atoms to exist. But as the universe cooled, the first atoms began to form. These were primarily atoms of hydrogen and helium, the simplest and lightest elements. But even as these atoms formed, the universe was not yet a place of light. The newly formed atoms were so hot and the universe so dense that any light produced was immediately absorbed. This was a period known as the Cosmic Dark Ages. In time, though, the universe continued to cool and expand, and it became less dense. Eventually, it reached a point where it was cool enough and sparse enough that light could travel through it. This was the birth of the cosmic microwave background, or CMB. This light, the afterglow of the Big Bang, is still detectable today, and it provides us with a snapshot of the universe at this early stage. As the universe continued to cool and expand, matter began to clump together under the influence of gravity. These clumps of matter became the seeds of galaxies and stars. Over billions of years, these seeds grew, drawing in more and more matter, and eventually igniting to become the first stars. These stars lived, died, and in their deaths seeded the universe with the heavier elements that would eventually lead to the formation of planets, and on at least one of those planets, life. From chaos, structure began to emerge, leading to the universe we recognize today. Fast forward to today, approximately 13.8 billion years later. We find ourselves in a universe that's a vast, sprawling canvas painted with cosmic wonders. It's not just a single galaxy we're part of, but a colossal cosmic dance of billions of galaxies. Each one a dazzling collection of stars, planets, and other celestial bodies. The universe is no longer a tiny, dense point. It has expanded, and it is still expanding. It's like a balloon being blown up, growing larger and larger with every passing moment. This expansion is a continuous process that started with the Big Bang and hasn't stopped since. In this grand cosmic theater, our Milky Way galaxy is just one actor among countless others. It alone is home to around 200 billion stars, and there are potentially more than 100 billion galaxies in the observable universe. If you do the math, that's a staggering number of stars, a number so large it's beyond human comprehension. But what connects all these galaxies, all these stars, and all this space? It's the Big Bang Theory. It's the theory that explains why the universe is the way it is today. It's the theory that tells us that all this vastness, all this complexity, started from a singularity, a point of infinite density and temperature. The universe's current state is a testament to its fiery birth and continual evolution. The Big Bang Theory is more than just an explosion, it's the story of the universe. To summarize, the Big Bang Theory begins with a singularity, a point of infinite density and temperature. This singularity was everything that existed, all matter, all energy, all space, and all time, condensed into an unimaginably tiny point. But it couldn't stay that way forever. In an event we call the Big Bang, this singularity exploded and began to expand. This wasn't an explosion into space, but an explosion of space. It's a subtle but important distinction. Space itself, along with all the matter and energy it contained, began to grow. And it's been growing ever since. As the universe expanded, it also cooled, and this cooling allowed for the formation of the universe as we know it. Matter grouped together to form atoms. Atoms grouped to form stars and galaxies, and over billions of years, the universe took shape. Today we live in a universe that's still expanding, still evolving, and still full of mysteries. But we've come a long way in understanding our cosmic origins. We've observed the cosmic microwave background radiation, a faint glow left over from the Big Bang. And we've seen galaxies moving away from us in all directions, indicating an expanding universe. We've discovered the abundance of light elements like hydrogen and helium, which aligns with the predictions of the Big Bang Theory. We should remember, though, that science is always a work in progress. The Big Bang Theory isn't perfect, and there are still many questions it doesn't answer, but it's the best explanation we have, based on the evidence we've gathered so far. The Big Bang Theory, while not perfect, provides the most compelling explanation for the universe's origin. It's a testament to the power of scientific inquiry and our relentless pursuit of understanding the cosmos.